In this video, what we're going to talk about is discuss and recall some of the properties of the remaining quadrilaterals. Then we will use the properties to solve for unknown angles in a quadrilateral. So we have here, we're going to talk about rhombus, we're going to talk about trapezoid, squares, and kite. So you have first the rhombus. We have the first property in terms of sides. We have there are two pairs of parallel sides. Then these are the parallel sides. That's the first pair, and the second pair is this one. Then all four sides are of the same length. That's the second property of rhombus. Then we have also opposite angles are equal. So it's the same with parallelogram. So we have a rhombus like this. If this is a rhombus, therefore this angle is equal to this angle, and this angle is equal to this angle. That's what this property is talking about. Then we have also the properties of rhombus in terms of the diagonal. The diagonals bisect each other at right angles. Meaning bisect, we explained that already before that. They bisect each other, meaning they cut each other into two equal parts. Meaning, when this, it means that when this diagonal cuts this diagonal, this side, this part here is now equal to this part. It's bisected. And the same so, this part of the segment is equal to this part. It's bisected. And not just that, they bisect at right angles. Meaning, during bisection, they form a right angle, meaning they are perpendicular. Then, another thing is the diagonals bisect the interior angles. What does it mean is that if you have a rhombus, and there's diagonal, this angle is bisected, meaning if this is A, this is also 80 degrees, meaning they are equal. The same so with this diagonal. This angle will be also the same with this angle. If that is B, this is also 80 degrees. So that's what these properties tell me about. So what we're going to do is, next is we're going to apply these properties, and with combination of these properties combining with those previous knowledge before are all about triangles, all about exterior angle, all about parallels and transversals. Then we'll combine those with these properties to solve for the unknown angles in a rhombus. So we have here, we're tasked to look for the value of A, or the angle A, and angle B. So notice that because according to the property of rhombus, this side is equal to this side, that gives us A is 38 because they are alternate interior angles. Okay? Okay. Next is B. In B, notice that because this is parallel, okay, this side is parallel, this whole angle here, and mind you, this is also A, because the diagonal bisect the interior angles, and meaning that that is A, that is also 38 degrees. So it's like saying that this whole angle here, this is 2 times 38 degrees. So that, remember, in parallelism with parallel lines with transversal, if you have two parallel lines and you have a transversal, this angle and this angle are supplementary. So meaning if you're going to add this angle here and B, that gives us supplementary, that those are supplementary angles, meaning when we add them, they are 180 degrees. So we say b degrees plus 2 times 38 degrees, because there are two 38s bisected by the blue diagonal line. That's 180 degrees. So simply subtract the 238 is 76. Subtract 76. So simply b is what's our reason here? They are consecutive interior angles. Okay, so b is 104 degrees. That's obtuse. Okay. So as you can see, it's like you're combining the previous knowledge, the previous concepts before, and the properties of your rhombus. So that is just actually the general strategy in solving for the unknown angle. Okay, combine what we have learned before and the properties of this. Next we have here what we learned about. These are opposite angles. Okay, these are opposite angles of the rhombus. So let us say this is rhombus, of course. What we learned about opposite angles of a rhombus is that if we're going to go back in the properties, the opposite angles are equal. So meaning we can make an equation of this saying 9x minus 2 degrees is just equals to 72 degrees. So we have 9x minus 2 equals 70. We're solving for technically x. Then we have plus 2 plus 2, we have 9x equals 72, so divided by 9 divided by 9, so x is simply 8. Okay, so what the important thing is you can set up an equation, a working equation, because if you have that equation you can work it out using simple linear equation. Okay, then the formation of that equation is actually based on the properties of the figure with respect to the given angles, using the properties of the figure and again the concepts before. Okay, so what is our reason here is that opposite angles are equal of a rhombus, particularly of a rhombus. Okay, so that's simply the reason why we're able to set up 9x minus 2 equals 7. So here we have also a rhombus. Let's take a look again. This is a rhombus. Okay, what we learned about the diagonals of a rhombus is that it bisects the interior angles. Okay, so what makes this important is that in this particular problem we're looking for y. And notice that since this line here bisects this gives us that this is also 40 degrees. Okay, now okay, we can use that 40 degrees and y to form a triangle. We're going to look at here. Okay, so we know that again the diagonals of a rhombus, they bisect each other at right angles, meaning this is the right angle here. This is 90 degrees. So meaning we can use the y degrees, the 40 degrees, and the 90 degrees. So we say y degrees plus 40 degrees plus 90 degrees equals 180 degrees. We have angle sum of each triangle. Okay, so look at this. We use two properties of rhombus and incorporate that to angle sum of a triangle. Okay, so what are the two properties? We know that the diagonal of a rhombus bisect the interior angles. That made us conclude that this is also 40 degrees. Number two, we know that the diagonals of a rhombus, they bisect each other at right angles. That gives us this 90 degrees. When we learn that, when we incorporate that, mix that together, we can form angle sum of a triangle as our working equation here. So yeah, this is 130 degrees. So therefore, subtracting 180 130 from 180, so you have y is just 50. Okay. Next, we have square. So in terms of parallel side, again, the same. There are two pairs of parallel side. All four angles are of the same length. All four sides are of the same length. All four angles are right angles, the same with rectangle. And here are the diagonals are equal in length. This is not the same with a rhombus. The diagonals bisect each other at right angles. Look at this. Okay, so it's the same with the rhombus. Then the diagonals bisect in the interior angles. It's again the same with rhombus. Now, here's the interesting part. Notice that diagonals bisect the interior angles. And if we're going to connect that here, since all four angles are right angles, and if we draw diagonal, it will, and we know that right angles are 90 degrees. So if we draw a diagonal, it will bisect at 90 degrees. So if you get what I mean, we have square. So let us say that we have a square here. We know by this property that this is 90 degrees. Okay. Now, if we using this idea, we draw a diagonal. We draw a diagonal there. Oh, let us say just simply like that. Oh. Like that. It bisects the 90 degrees. Now that gives us 45 degrees and 45 degrees. That is a very important property that very useful, and some cannot just see it. Okay. In especially when problems involving angles in a square becoming a little bit complicated. So let's try to apply these properties, and again combining with other lessons before about angles in solving. So we have here, this one is a diagonal. This one is a diagonal. That gives us 45. So notice, by just recognizing that that is a diagonal and it bisects the 90 degrees with 45, it gives you already angles in a triangle. Notice that you can add all these angles into 90 degrees. So you say 80 degrees plus 80 degrees plus 45 degrees plus 180 degrees. That is angle sum of the triangle. So you see, properties of a square, property of a square being diagonal bisecting the 90 degrees, being angles in a square, that makes 45, so it gives us again 180 degrees. So I think this one is 125. Subtracting 125 from that, we have 55. So A is 55. Next, we have here. There are many ways to solve this. Not really many ways, though. There's more than one way of solving this. But in this case, we know that this is also 60 degrees. Right? Why is that? Because they are parallel. And this is now transversal. So meaning this becomes angle in alternate interior angles. Okay. So from there, we can use this angles on a straight line and add all of them. So you have 70 degrees plus x degrees plus 60 degrees. They are all 180 degrees total angles on a straight line. Okay, so from there, this is 130, and subtracting 130 from 180, so you have x equals 50. Another method of solving this is without using 60. You can use 70. The 70, instead of using the 60, you can use the 70. You're going to there, that's also 70 by the same reasoning. Alternate interior angles. Now, if you have that 70, you can just add the 60, the 70, and the x being angles on a triangle. That's another alternative method. Next is we have the trapezoid. So trapezoid is kind of the a different kind of quadrilateral. It's because it has it's not like squares, rhombus, parallelogram, and rectangle. All this quadrilateral are somewhat sharing the same some properties. Okay, trapezoid is different because there is at least one pair of parallel sides. So this arrow here, arrowed sides, those are the parallel sides. So again, since there are parallel sides, we can still go back to the idea of parallelism with transversal. So if these are parallel, this becomes transversal, this becomes also transversal. Okay, so the same here. So the side, it can the trapezoid can look like this, being that one parallel. Okay, we have here, so we know that this is parallel, these are parallel rather, this one, and this acts as a transversal. So notice that they become consecutive interior angles. So we say 120 degrees, and we know in before's lesson, when we add consecutive interior angles, they are supplementary. So subtracting 20 from 180, so we have 5x becomes 60. Divide both sides by 5, we know that x becomes 12. So that's how. So what's the reason here? It's consecutive angles are supplementary, or simply add up to 180 degrees. Next, the same here. We are parallel, so just 3x plus 2x degrees equals 180 degrees. That gives us 5x equals 180. That gives us x equals 30 6, because we're going to divide both sides by 5. The same so with the 5y, because again these are parallel. So we have y degrees plus 5y degrees equals 180 degrees. The reasons are the same with this one. Since they are different variables, we can all add this. If they are kind of not these different variables, if in case we know that in a quadrilateral, when we add all the angles, it's 360 degrees. But in this case, we are not using the 360 idea because they are different variables, the y's and the x. So we have 6y and 180. That gives us y becomes divided by 6. That's 30. So y is 30. Next, the last one is the kite. Okay. So the distinguishing factor between kite and square and rhombus is that kite looks like there's a tail. Okay. Okay, so that's the longer version of the adjacent sides. Okay, the opposite side may be parallel. In strict mathematics, maybe means it can be or it cannot be. Meaning if it's parallel, it's still considered kite. If it's not, it's still considered kite. Okay. So here there are two pairs of equal adjacent sides. Unlike the other quadrilaterals, the opposite sides are equal. Like parallelogram, rhombus, kite, parallelogram, rhombus, square, and rectangle. Their opposite sides are equal. But in kite, that's not the case. The sides being equal are the adjacent sides. Okay, adjacent sides. So if we're going to draw a kite, that's the adjacent side. This one and that one. And the other two adjacent sides are also equal. This one and that one. So that's what it means when we say adjacent sides. This side adjacent to this are equal. Okay. Then we have also the diagonals cut each other at right angles. So here's the thing. Cut, it's not bisect. Okay, they do not bisect each other. So if you draw a diagonal here, they do not bisect each other. Okay, each other. They just simply cut, but it's at right angles. So it is really important that you memorize the properties of each quadrilateral. Okay, so at right angles. So here we go. This becomes 90 degrees here. Okay, but the next property tells us that one diagonal bisects the the interior angle. Okay, bisects the interior angle. So here we go. So if you have this, you're going to draw this diagonal. It bisects this angle, meaning this side angle is also equal to this angle, and the same so with this is also equal. So it's technically bisect the opposite angles there. So let's use this in solving unknown angles. So again, if we are going to have this and see if I'm going to draw a diagonal here, notice that it's like an isosceles triangle, and we know before the properties of a rectangle wherein if the angles opposite to the equal sides are also equal angles. So since they are equal sides, this gives us this angle is also equal to this angle, and the same so with these angles. This gives us angle is also equal to this angle. So it gives us that if we draw that diagonal, the kite will be divided into two isosceles triangles. Let's use that. So look at here. So since again you're using the previous knowledge, previous concept, this is also 5x because the opposite sides are equal. So from that, since that is triangle, so you can say 5x degrees plus that 5x degrees okay. So if we're going to subtract this becomes 10x degrees. If we're going to subtract that 50 from 180, you'll get 130 degrees. If we're going to do 10x equals to 130, therefore x is simply 30. So we use the property. What property we use? We use a property that the adjacent sides of a kite are equal. So that's making a isosceles triangle upon drawing a diagonal line. And this idea is still angle sum of triangle. Okay. It is important that you state right the reason, the rule. It's because in many cases answers can be correct, but the reasoning is wrong. Okay, it will be acceptable if answers are wrong due to error in computation, but the reasoning is correct. That's still acceptable. But if answer is right and the reasoning is wrong, that's not good at all. Maybe the correct answer is simply an accidental, by chance. Okay, we have here again. So again, if we are going to draw a diagonal, this diagonal bisect the interior angles. What does it mean? So this is 50 degrees. Since this is a bisector, this is also 50 degrees. And notice that this one can be added to 180 degrees because this is a triangle. Okay, so we have 2y plus 50 degrees plus 15 degrees, and this becomes 65 degrees. Total of 180 degrees. Again, angle sum of the triangle. Okay, so subtracting 65 from both sides, it's going to be 115. Dividing both sides, so you have y is equals to 57.5 degrees, or simply 57. So as you can see, we use the idea that one diagonal bisect the interior angles. That's why we concluded that yeah, this is 50 degrees, this is also 50 degrees. And the same, using the same reasoning, this becomes also 15 degrees, and we can also bring that there. Next is we have one property of a kite is that the diagonal diagonals cut each other at right angles, meaning this becomes 90 degrees here. So as you can see, this also 90 degrees. That becomes 90 degrees. Therefore, we can use this again, angle sum of a triangle. So we have a degrees plus 40 degrees plus 90 degrees equals 180 degrees. That gives us a being 50. Angle sum of a triangle. The same reasoning with this. So we have, this is also 90 here. So we have b 20 degrees plus 90 degrees equals 180 degrees. B being 7. So again, the same reasoning, angle sum of a triangle. But the angle sum of triangle is only for equation. Okay, it's only for equation. There are other properties that help form that equation. Okay, the rule is the angles of a triangle, but there are lurking underlying principle, and what's that underlying properties that help us to be able to make an equation, in this case angle sum of a triangle, because we know that this 90 degrees, we know that the diagonals cut each other at right angles. Okay, that's all for this video. So again, to recap, okay, to recap, when there is a problem, when there is a shape, look at the figure first. Is it a square? Is it a rectangle? Is it a parallelogram? Is it a rhombus? Is it a trapezoid? Go back to the properties of that shape or figure. Then when you know the property of the shape, you can now combine it with previous knowledge about angle sum of a triangle, exterior angle of a triangle, parallelism and transversals, parallel lines and transversals, and other factors like isosceles triangles, and combine it with the properties of that figure being mentioned. Then you can form equations. So that, just stick to that. So it is very important that you familiarize, you memorize the properties of its quadrilateral.